Hey guys, welcome back to another video. We're going to look at some probability in this new unit here. We're going to find empirical and theoretical. We'll get into what those are and the difference between the two. So first let's talk about an experiment. You get to control what's happening and you just see what happens as the results. The outcomes are the results, and the event is the subcollection of outcomes of the experiment. So when we talk about an event, we're just talking about like basically the outcome, sort of. Empirical is another word for experimental. So that's what you would actually see in doing an experiment. And if you use that when you cannot mathematically calculate based off of it. You just look at how many times the thing happened, the event happened, divide by the number of times that the experiment was performed. So you've probably done this many times, various styles, but maybe like flipping a coin. You actually flip a coin and you keep track how many times it landed on heads or whatever. That would be the probability of getting heads. How many times it landed on heads divided by how many times you flipped it. So here is an example. We're going to look at a pharmaceutical company, and they're testing a drug that's supposed to help with weight reduction. The drug's given to 500 people with the following outcomes. If the drug was given to an individual, find the empirical probability that the person's weight is, we're going to do all three: reduced, unchanged, and increased. So first, these numbers should add up to be 500 because everybody should have either had lost weight, no change, or gained weight. So for the probability that they reduced their weight, we take how many people were reduced divided by how many people total. For unchanged, we take how many people remained unchanged divided by 500 people total. And for increased, we take the 59 people divided by 500 total. Then we can get our calculator ready. And now all we have to do is just type in our probabilities that we got here. So 379 divided by 500. That's 75.8, and we're going to change it. We can change these back to percents. You can change them as the decimals. So we've got 0.758. Let's just do it as that. Let's do 0.758. But of course, you could think about that as a percent. It's almost 76%. Next one is 62 out of 500. That's 0.124. And then this last one here, 59 out of 500, it's 0.118. Now, one thing I want to just point out here is that these three numbers, 0.758 plus 0.124, plus 0.118. You add all of those up and you get 1 because that's everything that can possibly happen. Probability statements apply to a large number of trials, not just once, or not even just a couple. The larger, the better. It's the relative frequency over a long run that is accurately predictable, not individual events. So, for example, you might know that the probability of flipping a coin and it landing on heads is 1 out of 2 or a 0.5, but that doesn't mean that if you flip it, let's say you flipped it 9 times, you had 5 heads, 4 tails, that does not mean that the next one is guaranteed to be a tails. That's not going to guarantee that it's going to be 50-50, or it's not going to alternate heads, then tails, then heads, then tails, that sort of thing. But if you did it a lot of times, it would work out to be the correct the correct amounts. So here we've got theoretical probability. We're talking about it before we really spent much time about it, but it's a 1 out of 6 chance of rolling a 2. That is because there are 6 possibilities and only one of those has a 2. That's what theoretical probability is. They introduced this like in elementary school, so I'm sure you've seen this before. So we talked a little bit about empirical, but for everything else, we're going to look at theoretical probabilities, unless we talk specifically say otherwise. So for theoretical probability, you just take the number of outcomes that meet the requirement divided by the total number of outcomes. So like we said with the 2 on the 6-sided dice, rolling a 2, there's only one way to get a 2, and then there are 6 possible sides. That's actually true for any number on a dice, 1 through 6. So in this, outcomes are considered equally likely. So the probability of an event, not that it cannot possibly happen, like 0 chance would be probability of 0. Probability that it must happen would be a 1. That would be like 100% chance that it would happen. And then every probability should be between 0 and 1. The sum of the probabilities, we already did this, I showed you. When you add them all up, you get 1. And probability can be expressed as a fraction, a decimal, or a percent. We talked about that as well. We wrote it first as a fraction, then a decimal, and we talked about percents. If you're going to do a fraction, you should reduce it. So a 6-sided dice, what's the probability of getting a 3? Well, one of those sides out of the 6. So you can do it as a fraction, that is reduced. Probability of rolling a 7, well, none of the sides have a 7, so that probability would be 0. There's no chance of rolling a 7 on a single dice. Single die, rather. How about an even? Well, the even numbers, that could be a 2, a 4, or a 6. Those are the even numbers on a die. So that would be 3 possibilities out of the 6 sides total. 3 out of 6, which is 1/2. Again, just to remind you, that could be 0.5 or 50%. You can write it any of those ways. Reduced fraction, decimal, percentage, all that's fine. A number greater than 2. So we're only talking about numbers on a die, on dice. So numbers greater than 2. So not a 1, not a 2, because 2 is not greater than, but greater than would be 3 and 4 and 5 and 6. It's basically the same way of saying that. So that's 4 numbers out of the 6, which reduces to be 2/3. And again, you could do decimal or percent. A number less than 7, well, all the numbers on a die are less than 7, so that probability would be 1. Because every single number would meet that. If you wanted to write it out, you would say it's a 1 and a 2 and a 3, 4, 5, and 6. So all 6 numbers out of 6, which again would be 1. In an experiment, an event must either occur or not occur. It's like a light switch being on or not on. It can't be both. So the probability of something happening plus the probability of it not happening will always equal 1. And then you can just solve that out a little bit if you wanted to, make a different equation. That's what we did here. Alright, a standard deck of 52 cards. There's 4 suits, hearts, clubs, diamonds, and spades. Each suit has 13 cards. 1, which is an ace, through 10. And then jacks, queens, kings. So that's 10, 11, 12, 13 cards. Jacks, queens, kings are the picture cards or face cards. Hearts and diamonds are red. Clubs and spades are black. Hopefully you're familiar with the deck of cards. If not, take some time, play some games with cards and learn them. Number 1, it would be fun. Number 2, It'll help you out on these probability questions. Even if it's just like war or something like that. Look it up if you don't know how to play it. Alright, probability of a 5. So you got to think of how many cards are 5. We know there are 52 total. And then there's a 5 for each suit. So that'll be 4 different 5s in the deck. So 4 out of 52, which reduces to 1 out of 13. If we think a little bit differently about this, about each suit, there's 4 even suits. Each suit has 13 cards. Only one of those cards is a 5. That should make sense also. Alright, so the probability of not being a 5, well, that's the other cards. That'll be the other 12 out of 13 cards. That's the rest of them, and they have to add up to be 1. 12 13ths, 1 13th, that's 13 13ths. Probability of a diamond. Diamond is one of the entire sets, one of the suits of cards. There's 4 total, so that's 1 out of 4. Probability of a jack, a queen, or a king. So that's 3 cards there that we're saying is okay out of the 13 distinct cards that exist. 3 out of 13. Now this one says a heart and a club. So if you're looking at it, one card, what are the what's the probability that it's a heart and a club? Well, every card is only one of those things, not both. It can't be both of them. So it would actually be 0. There's no chance that one card is both a heart and a club. I could say like 5 and a club. That could work out, but not heart and club, or not diamond and club. You can't have 2 suits together. Alright, probability of being greater than a 6 and less than 9. So that's going to be the same for each suit. Greater than a 6 and less than 9. That includes the number 7, not the number 6. The number 8, but not the number 9, because 9 is not less than. So that's 2 numbers, 2 out of the 13. So that's 2 13ths is your probability. So remember, if it says and, it needs to be both of those things. Greater than 6 and less than 9. Put it together, that's only talking about 7 and 8. Hearts and club means it would have to be a heart and a club. When it's or, it's saying it could be any of those things, so you would add them up. Alright, that's it. Go ahead and finish up your worksheet, get it submitted, and I'll see you in the next video.